this video, we're going to talk about practice problems for MTE 6, exponents, factoring, and polynomial equations. Our first question is going to ask us to simplify the expression, the quantity negative 7x to the 8th times x to the 3rd. So we're going to drop the parentheses because it's all implied multiplication. That's negative 7 times x to the 8th times x to the 3rd. When I multiply like bases, I'm going to add the exponents. That's negative 7x to the 11th. Just like when I multiply like bases, I add the exponents. When I divide like bases, I subtract the exponents. So in problem number 2, I have 5 to the 6th, u to the 6th, v to the 8th over 5 to the 8th, u to the 6th, v to the 4th. So I'm going to subtract 6 from 8. That leaves me with 2 5s left in the denominator. All 6 of my u's are going to cancel to make 1s. And I'm going to be left with v to the 8 minus 4 is 4. I need to simplify this a little bit more because I can calculate what 5 squared is. 5 squared is 25. Number 3 asks me to simplify the expression s to the 6th t, all raised to the 2nd power. Well, that's going to be s to the 6th raised to the 2nd times t raised to the 2nd, because when I raise a power to a power, I multiply the exponents. That's 6 times 2, and that's 1 times 2. So this is 12. And this is 2. Now, when we have negative exponents, like in problem number 4, that asks us to find what negative 2 raised to the negative 6 is, we're going to take the negative exponent across the fraction bar and make it positive. If I leave nothing on the other side of the fraction bar, there's got to be a 1 there because there was an invisible 1 times that stays there as a placeholder. So negative 2 times 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 negative 2. That's an even number of negative signs. This is the same thing as negative 1 to the 6th times 2 to the 6th. This negative 1 to the 6th is a positive 1. 2 to the 6th is 64. So this reduces to 1 over 64. Five w to the 3rd divided by 4z to the negative 3rd with only positive exponents. So we're going to have to take the z to the negative 3rd across the fraction bar. Going to leave the 4 in the denominator because it does not have a negative exponent on it. It has a positive exponent of 1. It's only the z that has the negative 3 exponent sitting on it. So there we go. Number 6 asks us to use the rules of exponents to rewrite 2x to the 9th y to the 8th, that's in parentheses, all raised to the negative 4th power, using only positive exponents. So let's get, because these were all positive to start off with, let's get them down here in the denominator with a positive exponent on the outside. And that's going to give us 2 to the 4th is 16. X to the 9 times 4 is 36. Y to the 8 times 4 is 32, and I have a 1 as a placeholder in the numerator. Clear everything here. Now we want the numerator to have the quantity 2a to the negative 2 b to the fourth, and that's going to be raised to the fourth power, then multiplied times b, that's the end of my numerator. My denominator is going to be the quantity 6a squared b, close the parenthesis, all that raised to the third power. So let's go ahead and let's simplify. We're going to get rid of these parentheses here. 2 to the fourth is going to be 16. A to the negative 2 times 4 is negative 8. B to the 4 times 4 is going to be 16 times another b to the first over here. 6 to the third is going to be 36 times 6. It's 36. 18 plus 3 is 21. That's 216. A to the sixth, b to the third. Now we know that these twos are in common with those sixes. There were no threes in the numerator, so it's just going to be 2 to the third that's going to be able to come out. So it's going to be divisible by 8. So 8 goes into 16 2 times. 8 goes into 216. 20. 27 times. Okay, so we have 2 b to the 17th in the numerator. I'm going to take care of the a's right now, over 27. Bring that 8 down. 6 plus 8 is 14. Now I'm going to take care of, once I've gotten these b's combined in the numerator, 16 plus 1 is 17. Now I'm going to subtract 3 from 17, and that's going to give me b to the 14th in the numerator, 27a to the 14th in the denominator. All right. There it is. Now we're going to do some scientific notation. Get your calculators ready because we're probably going to need them. 9 5/10 times 10 to the fourth over 5 3/10 times 10 to the negative third. So we know what's going to happen with the exponents. The 4 plus the 3 is going to become an exponent of 7. But I need to figure out with my calculator what 9 5/10 divided by 5 3/10 is. I'm just going to pull up my calculator app here. And let's make it a little smaller so it doesn't take up so much of the screen. 9 5/10 divided by 5 3/10 is going to be, and I'm going to round this to 2 decimal places of precision because of my rules of significant figures, that this is going to only be taken to 2 significant digits, because there are only 2 significant digits in the numerator and 2 significant digits in the denominator. So I'm going to make that 1 8/10. For part B, we have 9 3/10 times 10 to the negative fifth times 6 times 10 to the third. It depends on how you look at the 6 here. I'm going to look at the 6 like it's an exact measurement here, and it's infinitely precise, that was not rounded. So I'm going to use two significant figures in my answer here. So when I take 9 3/10 times 6, I get 55 8/10. Times 10 to the -2. I need to make this 2 decimal places of precision here. So this is going to be 5.6 times 10 to the -1st, because I moved the decimal point back one already with one of these negatives. So I only need to move it back one more. This was, look at what this number was. It was 558 thousandths, and I wanted to round it to two significant digits. So I wanted to round it to 56 hundredths. So that's, I move the decimal point one to the right here. I need to have a times 10 to the -1 to move it back one more. That's what I did here. All right. Number 9 tells me that that I want to classify the polynomial below as a monomial, binomial, trinomial, or none of these. I see two terms of different degree, 8x to the 3rd plus 4x. This is degree 3. This is degree 1. Two different unlike terms. This is a binomial because it has two terms. Bi means 2, tri means 3, mono means 1. Now we're going to find the sum of the like terms, 17x and 5x. I can only add things together that are like terms that have the same degree. So 17 plus 5, keep the x, is 22x. When I multiply, the coefficient part, I'm going to multiply the variable part. This is going to give me 15y to the 3 plus 4 is 15y to the 7. When I divide by a monomial, like I'm going to in the next problem, I don't have to use long division because I can write each one of them over the monomial. Remember, with fractions, you can divide each of the terms in the numerator by the denominator if the denominator is a single term. So I'm going to have 10z to the 3rd divided by 2z plus 3z to the 2nd divided by 2z minus 2z divided by 2z. Then I can simplify each of those. The 2 goes into 10 5 times. Z to the 3rd minus z to the 1st, 3 minus 1, and be z squared. I said minus, I meant divided by, but I'm subtracting the exponents. I'm going to leave this 3 over 2 as 3 halves. Z squared divided by z is going to be z to the 1st, minus any number divided by itself is going to be 1. There we go. We're going to talk about subtraction of polynomials in just a second. First, we're going to find the sum, though, before we find the difference. So we've got 9x plus 4 plus 6x minus 6. I'm going to use my commutative property and associative property to say that this is 9x plus 6x plus 4 minus 6 is going to be 15x minus 2. Now, when we subtract polynomials, we need to add the opposite of the one that we're subtracting because we don't know how to subtract other than to add the opposite. So negative 5x plus 4 minus negative 3x plus 7. It's going to be negative 5x plus 4 minus a negative 3 is plus 3x minus a positive 7 is minus 7. So we're going to get negative 5 plus 3 for our coefficient on x. We're going to get 4 minus 7 for our constant. This is going to be negative 2x minus 3. Let's multiply these binomials now. We're going to use what we call the FOIL method to do this. It's just a acronym that stands for first, outside, inside, last. So we're going to multiply the first terms. Then we're going to multiply the outside terms, then the inside terms, and then the last terms. You're usually going to do that part in your head without writing it down. 5 times 9 is 45. X times x is x squared. 5 times 7 is 35x. 6 times 9 is 54x. 6 times 7 is 42. We're going to have to add these like terms in the middle here. This is an 89x. When we combine 35 and 54, we get 89 plus 42. We don't always have a binomial times a binomial, so when we multiply, we're going to have to look down here at number 19 how we're going to do it when we have more terms, but it's the same idea. We'll get there. Let's find the difference now of 5x squared minus 2x minus 3 minus the quantity 3x to the third minus 9x squared minus 3. So I'm going to start lining things up vertically. I'm going to do this as an addition problem. So this is going to be a negative 3x to the third plus 9x squared plus 3. So I'm going to add my like terms together. 5 and 4 add together to give me, 5 and 9 add together to give me 14. Negative 2 and 0 add together to give me negative 2. Negative 3 and 3 add together to give me 0. I won't write that term because it's 0. All right. Perform the indicated operation and simplify. Negative 5x to the fourth plus 8x squared plus 2 plus 7 times 5x to the fourth minus 3x squared is going to give me negative 5x to the fourth plus 8x squared plus 2 plus 35x to the fourth minus 21x squared. 35 minus 5 is 30, x to the fourth. 8 minus 21 is going to be negative 13. Find my x squared terms plus 2. Me crossing things out does not mean that I've zeroed them out. It's me saying I'm done with them and that I accounted for them. So I cross things out that are my like terms when I've added them together. So just be aware of that if you are following back with me and you see things crossed out, that did not mean that I zeroed things out. All right, find the difference. Negative 7x squared minus 7x minus 7 minus big bracket, open parentheses, 7x to the third minus 9x squared. I'm just going to need some space here to figure out each of these things individually. So let's go ahead and let's figure out this second part first. 7x to the third minus 9x squared minus 20 plus 4x minus 11. Let's figure this out. That's the thing that I'm subtracting from the original. So this is 7x to the third minus 9x squared plus 4x minus 31, right? I'm going to subtract that, so I need opposite signs. Subtract it from the original, negative 7x squared minus 7x minus 7. So this is going to be 24. This is going to be negative 11. This is going to be positive 2. And this is going to be negative 7. Now it's number 19, where I promised you I would show you what happens when you have more than a binomial times a binomial. We're going to have x squared plus 4x minus 3 times 5x squared plus 7. So we're going to take x squared times 5x squared plus 7 plus 4x times 5x squared plus 7 minus 3 times 5x squared plus 7. Same idea. We're taking each thing in the first polynomial, multiplying it over top of the entire second polynomial. And that means that everything in the first, every term in the first polynomial is going to get multiplied to every term in the second polynomial is really what that's going to come down to. So this is going to be 5x to the fourth plus 7x squared. Then we're going to have a 20x to the third and a 28x. We have a minus 15x squared and a negative 21. I'm just lining up my like terms here, 5x to the fourth plus 20x to the third minus 8x squared plus 28x minus 21. The only like terms that I had were my x squared terms. Now we want to find the greatest common factor in problem number 20 of 9g to the third, h to the seventh, 3g to the ninth, h to the eighth, and 3g to the second, h to the eighth. So we're looking for fact that this one is 3 squared, g to the third, h to the seventh. This one is 3 to the first, g to the ninth, h to the eighth. And this is also 3 to the first, g to the second, h to the eighth. All right, we're looking for the smallest exponent that is in everything. So with my 3's that I have in common in all of them, the smallest exponent is 1. My g's that I have in everything, the smallest exponent that I have is 2. And my h's that I have in everything, my smallest exponent is 7. So my GCF that divides into everything evenly is going to be 3g squared h to the seventh. Okay. Did that because that's going to be part of our factoring that we're going to do next. We're always going to try and factor out the GCF. So here's a GCF factoring problem, 3xy plus 15x squared y minus 21x to the sixth y to the sixth. I see that 3 goes into all of them evenly, x goes into all of them evenly, y goes into all of them evenly. I have 1 plus 5x minus 7x to the fifth, y to the fifth, and I'm done. I can't factor that trinomial anymore. The next one tells me to factor by grouping if possible, 4y to the third plus 3y squared plus 28y plus 21. I'm going to group the first two and the last two. If this is a subtraction sign, remember to make it plus a negative and keep a positive, a plus sign between the two sets of parentheses here. I'm going to pull out the greatest common factor here. I'm going to pull out the greatest common factor here. If this is factorable, then those two sets of parentheses there have to match and have to be a greatest common factor that I can pull out. And I'm left with these parts here. Back to the trinomial, if possible, z squared plus 14z plus 48. So we're going to want to try and factor it into two binomials since the leading coefficient is 1 here, and I don't have a greatest common factor. Z times z gives me z squared. Factors of 48 that add to be 14 are 6 and 8. Next, we're going to try to factor m squared minus 7m minus 120. Factors of 120 that have a difference of 7. List the factor pairs of 120. So they're going to have different signs, and the bigger one's going to be negative. No, 7, 8, and negative 15. There we go. That's it. So m plus 8 and m minus 15. They add together to give me a negative 7. All right. Now let's factor 3z squared plus 30z plus 27. First thing I have to do is factor out the greatest common factor. Now I need factors of 9 that add to give me 10. Like that, and I'm done. Number 26 asks me to factor 20g squared minus 63g minus 21 to factor that completely. So because the leading coefficient is not 1, I'm going to use that method of the AC method that I was using just a minute ago to say that they need to multiply to give me negative 420. It's a big number, right? And need to add to give me a negative 63. So this is going to be pretty some pretty big factors here. Let's see here. 2 and 210, and then 3 and negative 140, then 4 and negative 105, 5 and negative 84. 6 and negative 70. 7 and negative 60. Not 8. Not 9. 10 and negative 42. Not 11. 12 and negative 35. Not 13. 14 and negative 30. 15 and negative 28. 16, nope. 17, I don't think so. Close my calculator already. Let me get my calculator back. So 420 divided by, let's just check some of these numbers that I skipped. 8. Nope. 420 divided by 9. Nope. 420 divided by 11. Nope. 420 divided by 13. I'll explain why I'm trying to get all these. Let me see what the square root of 420 is. I'm getting close. Okay, so I need to go to 20. 420 divided by not 16, not 420 divided by 17. Nope, 420 divided by, can't be 18 because there was no 9. 420 divided by 19. No. Okay, so I'm done because there's 20 times negative 21. All right, now I'm looking for which factor pair adds together to give me negative 63. If you've been trying this while I've been figuring all this out, you're going to see that the closest ones are here and here, that this adds to give me negative 64, I'm sorry, here and here. And this adds to give me negative 53, and negative 63 is somewhere between here, and I haven't skipped any factor pairs, so I know that this is prime, and I've proved it that there is no factor pair of negative 420 where I can split the middle term up to give me a sum of negative 63 where I can factor it by grouping. It's just not going to work. And there was no greatest common factor here to start off with, so it's prime. That took a lot of work to prove that to you, but we can't just try some and then stop when we get frustrated. We have to show the teacher that we have examined everything. So we have looked at all possibilities. All right, difference of squares, 52x squared minus 81y squared. This is 5x quantity squared minus 9y quantity squared. We're going to write this as a difference of squares, 5x minus 9y, 5x plus 9y. Whenever I have a squared minus b squared, it factors into a minus b times a plus b. I could write it also as a plus b times a minus b. The order of multiplication does not matter. So Sometimes I'll write it one way, sometimes I'll write it the other way. Doesn't make a difference. Let's factor the sum of cubes. 27m cubed plus 64n cubed is going to be 3m cubed plus 4n cubed. That's going to give me 3m plus 4n times 9m squared minus 12mn plus 16n squared. That's because a cubed plus b cubed is always equal to a plus b times a squared minus ab plus b squared. A cubed minus b cubed, when we get to that one, is going to be a minus b times a squared plus ab plus b squared. So this is always the same sign. This is always the opposite sign. This is always a positive sign. I remember SOAP to help me remember the order of my signs. I have to remember the rest of the formula, but my signs are always same, opposite, always positive. Spell SOAP to me. In fact, there's my difference of cubes right there. This is z cubed minus 5 cubed. This is z minus 5 times z squared plus 5z plus 25. Now we're going to solve 2x squared is equal to 76x. By factoring, we're going to have to bring everything over to the left-hand side. Set it equal to 0. We're going to factor out 2x. X minus 38 equal to 0. So 2x equals 0, or x minus 38 is equal to 0. X is equal to 0, or x is equal to 38. A second degree polynomial is going to have at most 2 answers to it. This is going to be what's called the fundamental theorem of algebra, that an nth degree polynomial can have at most n real solutions to it. Pretty important, it's fundamental. Now we're going to solve this equation by factoring a squared plus 8a plus 29 is equal to 13. Well, we're going to subtract the 13 from both sides to get started, because we want the right-hand side to be equal to 0. Now what we have here is a special case that is a perfect square trinomial, because 16 is 4 times 4. 4 plus 4 is 8. So this is really a plus 4 quantity squared, because it's the same thing, a plus 4 times another a plus 4. 4 times 4 gave me 16. 4 plus 4 gave me 8, but since it's the same thing twice, I can write it with exponential notation, like we've been doing. That allows me to say, well, I don't need to write the same answer twice. I can say a plus 4 equals 0, a equals negative 4, and I'm going to call this right here a multiplicity of 2, because it was an answer 2 times. We'll learn why multiplicity is important later in pre-calculus. It has to do with whether it crosses or touches the x-axis at that 0 of the polynomial. So I'll tell you right now, though, even multiplicities are going to touch the x-axis. Odd multiplicities are going to cross the x-axis. We're not to graphing these yet. We might talk about that a little bit with MTE 9 when we get to quadratic equations and graphing them. Let's see here. Scroll down a little bit. Now we're going to solve by factoring x to the third minus 17x squared plus 72x is equal to 0. So first things first, we're going to take out the common factor of x. And we're going to factor the remaining trinomial into two binomials. Signs are the same, they're both negative. Factors of 72 that add up to be 17 are going to be 8 and 9. So x is equal to 0, or x minus 9 equals 0, or x minus 8 equals 0 is going to be x equals 0, or x equals 9, or x equals 8. So I'm going to give a solution set of 0, 8, or 9. An object is thrown upward from a height of 192 feet. It's going straight up and coming straight down. Right? But starting here, when t equals 0, it's going to be 192 feet. It's thrown with a velocity of 64 feet per second, and the initial height in feet is 192. They give you the physics equation there. I'm just going to write it out here, that h is equal to negative 1/2 g t squared plus v naught t plus h naught, like that, where g is the acceleration due to gravity. In this case, since we're talking about feet per second, then this is going to be 32 feet per second squared. So half of 32 is 16, make it negative because it's moving down towards the earth. The initial velocity here was 64 feet per second. And we had an initial height of 192, and that's where they got their equation from. Don't worry, you're not going to need to make this equation for a little bit, but you will have to do it in physics class. You might have to do it a little bit in calculus class. This is a function of time t. So they want us to figure out how long will it take for the object to hit the ground. Ideally, that 16 is going to factor out of everything. Let's see if we can make that happen. Is 192 divisible by 16? Yes, 12. So h of t negative 16 times t squared minus 4t minus 12. So we've got negative 16 t minus 6 times t plus 2. We want to find out when it hits the ground where the height is 0. So that's not going to be because negative 16 is 0. That's going to happen because t minus 6 equals 0, or because t plus 2 is equal to 0. So t is either equal to 6 or t is equal to negative 2. Time can't be negative though, so we're going to be looking at an answer of 6 seconds after release is when it's going to hit the ground. Last problem, number 34, asks us the revenue from the sales of a camera given by R is equal to 55x minus x squared, and the cost of producing x units is given by 99 plus 35x. You need to know that capital P profit is equal to revenue minus cost. So my profit function, because they're asking us to break even, which means that we're going to make 0 profit, is going to be 55x minus x squared minus 99 plus 35x. Capital P of x is going to be negative x squared plus 20x minus 99. So we want to set profit equal to 0 when we're going to break even. This is the same thing as if I bring everything over to the other side of the equation. X, both negative, and this is going to be 9 and 11. X equals 9 or X equals 11. So I don't have much of an area between 9 and 11. I have exactly 10 is going to be the only place where I would make a profit in this model. That's not very good. So I have a quadratic equation here that expresses my profit. And it crosses at X equals 9, and it crosses again at X equals 11. And everywhere to the left of 9, I have negative profit. I'm losing money. Everywhere to the right of 11, I have negative profit. I'm losing money. My maximum value here is going to be X equals 10. And I'm not going to make much money here. This is not a business that I should go into because I would have to sell exactly 10 cameras to make any money. So there we go. That is everything for this video. We'll come back next time and talk about MTE 7, which is going to be rational expressions and equations.